This is chapter 14D of the textbook, and it's about the addition and subtraction formula for trigonometric functions. So, although we have ways to remember some of the values for, say, sine theta, cos theta, or tan theta, and we can use our knowledge of the unit circle and triangles. So, we tend to put into memory that sine pi on 4 or 45 degrees is 1 on root 2, or root 2 on 2. But for some angles we don't know, and we don't stick these to memory. So what if we wanted to find the values of functions such as sine 75 degrees or cos pi on 12 or 15 degrees without a calculator? In these cases, we can use addition formula to help us. So what we do is we try and break down an angle into the sum or difference of two angles that we know, such as 30, 45, 60, 90, 180, or 360 degrees. Let's have a look. So we have a formula for sine, cos, and tan. For sine, when we have, say, 75 degrees, I break this down into two angles that I know. So 75 is the same thing as sine 45 plus 30. I know what sine 45 is, and I know what sine 30 is. So I can use that first formula that we see. We have an alpha plus a beta. Alpha is my 45, beta is my 30. So I could say that sine 45 cos 30 plus, then the other way around, cos 45 times sine 30. And I add these values together. That way I can find what sine 75 degrees is. I could also use it to say find sine of 15 degrees. Because again, I know what 45 degrees is and I know what 30 degrees is. So this time I'd use the formula for sine 45 minus 30, where 45 is my alpha, beta is my 30. I'd have sine 45 cos 30 minus cos 45 sine 30. So notice here how sine likes to share. Whenever you see a sine, there'll be a cos. So you always have sine alpha cos beta. Then notice that the plus or minus is the same as what we do in our initial brackets. After our plus or minus sign, we have cos alpha times sine beta. Those are the addition formula for sine. For cos, it's a little bit different. So cos likes to stick to itself. So for cos alpha plus beta, we have that is equal to cos alpha times cos beta. So the cos's stay together, minus the opposite sign, sine alpha, sine beta. For cos alpha minus beta, we have cos alpha cos beta again, but this time's plus sine alpha sine beta. Example 1. Evaluate the following. So we're going to try and find sine of 5 pi on 12 in radians. So firstly, we've got to think about, okay, well, what is 5 pi on 12 radians? I'm going to convert it to degrees so it's a little bit easier. So we can say 5 times 180 divided by 12, well, that's 75 degrees. I can break 75 degrees, like we said before, into 45 degrees plus 30 degrees. So let's rewrite it. Sine 5 pi on 12 can be broken down to sine 3 pi on 12 plus 2 pi on 12. That will give me 5 pi on 12, and also 3 pi on 12 will simplify to pi on 4 or 45 degrees, and 2 pi on 12 simplifies to pi on 6 or 30 degrees. Now let's look. I'm going to label my pi on 4 as alpha, my pi on 6 as beta, and notice I have a plus sign in between them. So then I look at the top of my formula and I think, what formula does this work for? I have a sign, and it's the very first one because I have a plus in the middle. So using the formula, we have sine pi on 4, that was alpha, times cos of beta, pi on 6, plus cos alpha, pi on 4, times sine beta, pi on 6. Now, if you can't remember what sine pi on 4 or cos pi on 6 is, remember you can always draw your unit triangle, similar to on the unit circle. Now I can see straight away, well, sine pi on 4 would be 1 over root 2. Cos pi on 6, remember that's the adjacent side I'm looking at here, would be root 3 on 2. Cos pi on 4, well, that's 1 on root 2 as well. And then sine pi on 6, well, that's opposite over hypotenuse, that will be a half. All I have to do now is just expand this and simplify where possible. So the base value on the denominator is 2 root 2, and I have root 3 plus 1 on the top. To rationalize, multiply the denominator and the numerator by root 2, and we'll end up with root 6 plus, well, 1 times root 2 is root 2, all over 2 root 2 times root 2. Well, that's just going to be 2 times 2, or 4. So finally, sine 5 pi on 12 is really root 6 plus root 2 all over 4. Next example, we're going to stick with sine for this one. Let's do example 2 here. It says if sine u equals 12 over 13 and sine v equals 3 over 5, where u and v are obtuse angles, find sine u plus v. So we're going to keep that obtuse angles in the back of my head. I know that in radians, an obtuse angle is between 90 degrees, or pi on 2, and 180 degrees, or pi radians. What we're going to do first is write out the formula for sine u plus v. U is like your alpha, v is like the beta. So again, first line, first formula. I have sine u plus v would equal sine and cos. So sine u cos v plus, stick with the same sign here, cos u sine v. And now I know some things. It tells me that sine u is 12 on 13. It also tells me that sine v is 3 on 5. So I'm going to sub these values into the equation that I just wrote out. I have sine u plus v equals, well, sine u was 12 on 13. I don't know what cos v is yet, so I'm going to leave that there. Plus cos u, not sure, but sine v, I know that is 3 on 5. Now your job is to find cos v and cos u. You can use either right angled triangles, or you can use the Pythagorean identity that sine squared theta plus cos squared theta equals 1. I'm just going to use right angled triangles here because I think it's a little easier, especially with the values that we've been given. So if I have a right angled triangle, and I know that sine u is 12 on 13, that means the opposite angle is 12, the hypotenuse is 13. I also can draw another triangle where sine v is 3 over 5, so opposite is 3, hypotenuse is 5. Now I can use Pythagoras to work out the missing adjacent side length. So I'm going to find x, and I'm also going to find y in these two diagrams. Luckily, y is very easy. I know that 4 squared plus 3 squared equals 5 squared. The same with the x. X should be equal to 5 because 5 squared plus 12 squared equals 13 squared. This is nice because now I can find cos v and cos u. So cos of u would be my adjacent over hypotenuse, 5 over 13. Cos v the same, I'd have 4 over 5. But there's one catch. We have to recall where U and V are obtuse angles. So that means cos is in segment 2 of our unit circle. And for obtuse angles between pi on 2 and pi, cos is negative. So for cos U, I'm just going to stick a negative in front of the 5 on 13, the same as cos V. That's also obtuse, so my cos values are negative, minus 4 and 5. Now I'm going to sub these back into my equation. So I have 12 over 13 times, I know what cos V is now, minus 4 over 5, plus cos U, minus 5 over 13, times sine V. Well, sine V was just 3 over 5. Okay, put it all together, we're going to get something over 65. So I have minus 48 over 65, minus 15 over 65. Last step, let's subtract, and I'll get minus 63 over 65. Last question, we're going to use tan. So tan has its own formula here. Now what I like about tan is a bit of a loner, right? It's a bit separate, it's a bit different to the other two graphs, and it sticks by itself. So notice that we have tan alpha plus beta. We'll have tan alpha plus tan beta on the numerator, but then the sign swaps to negative on the denominator. The same if we have tan alpha minus beta, we have a minus on the numerator and a positive on the denominator. All right, let's take a look at the example using the formulas above. So if U minus V is acute and tan U equals 4, tan V equals 3 on 5, show that U minus V is pi on 4. So I know that tan U minus V, I'm going to choose the second formula here, would be equal to tan U minus tan V over 1 plus tan U tan V. Now let's sub in. I know tan U is 4, I know tan V is 3 on 5, so I just put these into our equation straight away. Here's what we end up with. I'll get 4 minus 3/5 divided by 1 plus 4 times 3/5. You can put this into the calculator or do it in your head, up to you. But in the end, I think we'll get something like 17 on 5 for the numerator and 17 on 5 for the denominator. Well, that's just equal to 1. So I know that tan U minus V equals 1. I've got to find UV. So notice here that U minus V is an acute angle, okay? So tan U is positive, tan V is positive, and if U minus V is acute, that means U minus V must be in my first quadrant of my unit circle. And I know an angle that's acute, that tan is equal to 1. And I think you know the answer as well. If I make my tan triangle right here, U minus V is the angle. I know that tan U minus V equals 1. And in the acute, I should get that U minus V is equal to pi on 4, right? Or 45 degrees. This is the triangle I would create in the unit circle. You can also use the inverse of tan to find the answer as well. Okay, so make sure you've copied down the formula in your books or resource books and then attempt the lesson on OneNote.